Volcanoes are already among the most terrifying natural forces in the world, but there's a new menace on the rise that may transform the way we perceive geological risk forever. A new study, supported by sophisticated satellite power and deep-sea equipment, has revealed something secret beneath the Earth's surface, something never considered before. Far beneath the Atlantic Ocean, researchers have detected indications of a colossal geologic system, not on some remote landmass but smack in the middle of the oceanic floor. What originally appeared as delicate seismic twitches has now emerged as something much more ominous: indications of a waking supervolcano. The Atlantic Ocean was always an enigma, large, deep, and mostly unknown. Though the surface is tranquil, beneath the ocean floor, another tale is being written. In recent times, unusual anomalies under the sea have piqued the interest of scientists. Initially, the seismic irregularities were attributed to data glitches, monitoring system errors. However, as the unusual patterns persisted and unusual heat signatures and underwater noises followed, researchers had no option but to probe further. What they discovered wasn't only unexpected, it was horrifying. They had found something enormous, explosive, and hitherto unknown: a gigantic magma chamber. Due to a strong collaboration between NASA, global geological expeditions, and underwater research probes, the enigma began to be unraveled. With the help of sophisticated satellite imaging, deep-sea seismic sensors, and heat mapping, scientists verified that this was not a small geological structure. Underneath the mid-Atlantic ridge, there is a gigantic magma chamber extending hundreds of miles. It's not merely a volcanic system, it's a supervolcano. And that makes all the difference. The pressure accumulating in that chamber is already on par with some of the worst eruptions in the history of our planet. The energy trapped under the waves is mind-boggling. A supervolcano of this magnitude covered by the ocean may be able to produce events that reshape the world in the blink of an eye. We're talking about potential tsunamis that could sweep across continents, volcanic ash that could block out the sun, and undersea collapses that could trigger massive chain reactions. The eruption of such a formation could create a ripple effect of disasters, crashing ecosystems, damaging transatlantic infrastructure, disrupting air travel, and plunging regions into a deep, volcanic winter. At a time when climate change already poses a threat to global stability, this latest discovery is a grim reminder of how delicate our planet's balance actually is. NASA's confirmation is a watershed moment not only in the research of volcanoes but in global readiness. For the first time, mankind has to seriously consider the threat that a sleeping monster beneath one of the world's busiest oceanic paths poses. The scientific world is now advocating for international cooperation, warning systems, and more investments in monitoring the ocean. This is not merely an exciting scientific discovery, it's an alarm call. We now understand there's something menacing developing below the Atlantic, and the countdown could already be running. The actual discovery happened unobtrusively, with data rather than with bombs. Early in 2025, satellites that monitor the Earth started detecting unusual thermal signals below the surface of the Atlantic Ocean. Meanwhile, deep-sea probes detected minor variations in the height of the ocean floor. Although these variations were minor, a few centimeters, they were not typical. More significantly, they were not compatible with normal tectonic movement. This prompted scientists to investigate further. What they found was nothing short of remarkable: a magma chamber more than 300 miles wide directly under the mid-Atlantic ridge. This ridge has been geologically active all along, but this new information painted a different picture. Unlike the typical fault line activity, the seismic shutters coalesced in unusual patterns that indicated the movement of magma, not moving plates. Sonar imaging verified a bulge in the seafloor, rising steadily month by month. That's a sure indication of something enormous building up below. As scientists excavated deeper, they saw that they weren't observing typical volcanic activity. They were seeing the creation, or awakening, of a geological giant. One that might match or even exceed some of the world's most perilous known volcanoes. To verify their discovery, scientists sent autonomous deep-sea vehicles, or ADSVs, to the location. These autonomous explorers, with their thermal sensors, sample arms, and cameras, managed to enter fissures and vents on the floor of the sea. They fetched rock samples, measured underwater releases of gas, and noted temperature signatures. And what they observed was concerning. There were large amounts of sulfur dioxide, argon isotopes, and helium-3 gas normally seen only under deep activity within the mantle. This meant that what they were observing wasn't a superficial volcanic process. It was something more profound, older, and much stronger. The information didn't end there. Thermal cameras taken beneath the surface showed unprecedented venting along parts of the mid-Atlantic ridge. These sites had previously been inactive in scans before. Now they were radiating heat, emitting jets of hot gas and mineral-laden fluids into the ocean. This type of venting occurs only when the magma is nearly ready to breach. Adding the rising ocean floor and aberrant seismic activity, scientists had more than sufficient reason to identify this area as an active supervolcanic field. What's more alarming, however, is how rapidly the system is heating up, much quicker than scientists anticipated. Having such an immense, invisible system raises questions about what, precisely, constitutes it a supervolcano? Unlike typical volcanoes, which build mountains or conical mountains, supervolcanoes aren't always showy on the surface. They instead create giant underground magma chambers. When those chambers erupt, they don't just spit out lava. They explosively shatter whole landmasses, forming humongous calderas hundreds of miles across. For the Atlantic supervolcano, sonar mapping has uncovered what looks like the edge of a huge ancient caldera, evidence that this location has erupted in the past on a truly planetary scale. A supervolcano isn't simply defined by its size, but by its impact. The cutoff for being considered a supervolcano is an eruption that spews out more than 1,000 cubic kilometers of material. That is enough to blanket entire nations in ash, toxify the air, and dramatically cool the Earth's climate. That is the characteristic of the new Atlantic system revealed by these studies and more. Not only is it volumetrically gigantic, but even the magma itself has a high content of gases, such as carbon dioxide and sulfur dioxide, which make it explosively eruptible and unpredictable. This is not a sleeping relic, it's an open threat. More disturbing is the chemistry of the magma. It tested at high levels of rhyolitic material, a silica-dense magma with a reputation for thickness and explosiveness. Thick magma locks in gases, building internal pressure. When that pressure is released, it explodes. The Atlantic chamber is really one huge pressure vessel, with noxious gases piling up beneath a thin shell of rock. If it were to blow, it might be able to hurl ash and gas into the sky with sufficient intensity to change climate patterns worldwide, impact agricultural productivity, and potentially produce years of cooling. Among the most horrifying findings were produced by gravitational anomaly mapping. Researchers employed satellites to gauge the Earth's gravity field across the region and found anomalies indicating that the chamber is constantly supplied with material from deep in the Earth's mantle. That is to say, this is not some temporary threat. Even if smaller eruptions or venting bleed off pressure, the supervolcano might stay active for centuries, gradually recharging, gradually expanding, an ever-present danger. Its underwater position makes it more difficult to observe than volcanoes on land, and that's an added level of risk. Without obvious visual cues, we might have fewer minutes to respond if it does erupt. Unlike Mount St. Helens or even Yellowstone, we don't have a mountain to observe or a crater to examine. We're working with something unseen beneath the ocean and perhaps much more potent. If it erupts, it won't just affect surrounding nations. It might shift the global equilibrium of ecosystems, commerce, and even farming. That's because the aerosols emitted would be able to chill the world by a few degrees, as past supervolcanic eruptions have already shown. Crops would perish. Supply chains would break. Governments would panic. And all this would start below the Atlantic, where hardly anybody is paying attention. The chance for catastrophe does not stop at the eruption itself. Submerged beneath the ocean, this volcano threatens differently. In case the chamber ruptures, an underwater explosion might displace vast quantities of water, leading to mega tsunamis. Waves estimated by some models stand at more than 300 feet high and will hit coastal areas in the entire eastern part of the United States, South America, Western Africa, and most of Europe. New York, Lisbon, and Rio de Janeiro might be erased within hours. Whole economies might be destroyed. And unlike the earthquakes that generate traditional tsunamis, these would arrive with virtually no warning. That's the frightening force of this stealthy monster, one that doesn't bellow till too late. Core samples taken from deep-sea drilling operations have provided chilling evidence that the Atlantic supervolcano is far from myth. These samples exposed layers of volcanic glass, pumice, and dense sulfur deposits, each signifying violent supereruptions in the distant past. The information indicates that these layers are more than 200,000 years old, making it certain that the magma chamber under the Atlantic Ocean isn't a new geological phenomenon. It's an awakening monster slowly rising. What's even more alarming is that the magnetic anomalies in the seabed around the area correspond to those in known calderas, the areas of collapse that remain following enormous volcanic eruptions. In plain language, nature has provided hints, sounding loud and clear, that the region has erupted previously in catastrophic fashion. Outside of mere physical samples, radiometric dating of sediments extracted from the ocean floor has attested to at least 3 significant eruptive episodes having occurred here. These weren't minor eruptions of lava. These were broad-scale explosions followed by tens of thousands of years of inactivity. This periodic schedule creates an ominous scenario, that this volcano doesn't simply erupt, it operates in a pattern of dormancy and devastation. Some of the most compelling evidence is found in the crystals, zircon to be precise, recovered from boreholes. Such crystals are capable of withstanding incredible pressure and retaining isotopic signatures for millions of years. Their internal structure reveals magma that has remained buried, under tremendous pressure for thousands of years before finally erupting. That kind of conduct is a warning sign. It indicates this volcano can remain dormant for centuries, and then blow its top with catastrophic fury. And adding to the alarm, ocean sediment cores have revealed thin layers of volcanic ash interspersed with layers of clay covering huge ocean areas. These layers of ash aren't haphazard. They correspond to the distinctive chemical fingerprints in the Atlantic magma chamber. This confirms that previous eruptions were so intense that their detritus blanketed entire ocean basins. That kind of extent isn't regional, it's global. It means that this volcano has already shown the potential to affect the whole Earth's atmosphere, marine life, and even global temperatures. This is not a theoretical threat. It has already occurred, and it can occur again. One of the more unexpected findings during geological surveys was the discovery of what seemed to be remnants of collapsed domes buried under the ocean floor. With sub-bottom radar profiling, researchers were able to break through layers of sediment and reveal ancient structures below. These structures are similar to what occurs after a volcanic eruption when new magma re-enters the chamber, pushing upward and doming before collapsing once more. This resurgence activity is typical of supervolcano systems. It implies that this is not an isolated, explosive event. It's one phase of a cycle of eruption, healing, and ultimate re-eruption. Every chapter contributes to the narrative of a volcano that has already molded the planet once, and might do it again. All of this geological testimony, core samples, chemical signatures, crystal timelines, and structural leftovers, coalesces into a persuasive and chilling argument. This volcano exists. It is alive. And it already reshaped the world once before. With today's indications of instability, the sequel could be far sooner than anybody thought. Scientists at NASA and the USGS are currently tracking it with mounting urgency, not because tomorrow it will erupt, but because the initial signals are piling up at an accelerating rate. Even with the mounting evidence, however, both NASA and the US Geological Survey point out that there's no immediate reason to panic. An eruption might not occur next year, or even next decade. But what they're observing is enough to raise serious red flags. Underwater robots sent into the area have captured images of new cracks opening up on the rim of the caldera. Some of these fractures are emitting superheated gases at record levels. This type of outgassing has in the past led eruptions in other volcanic systems. It's a pressure release, and when pressure gets too high, it has to go somewhere. Another troubling trend is the continuous inflation of the ocean floor. Deep-sea pressure gauges are exhibiting slight but recurring bulging throughout the region, a classic indicator that magma is piling up under the crust. But it's not a local phenomenon. Satellite heat imaging is now picking up on heat patterns emanating from the central core of the caldera, showing that the heat is spreading. This type of widespread pattern of heating indicates the magma is in motion, building pressure and possibly weakening the crust over it. That's when eruptions are not only possible, but probable. Tossing in another element of risk is the existence of methane clathrates, ice crystals that contain methane gas trapped under the ocean floor. These substances are being destabilized by increasing heat. When released, methane works as an accelerant, fueling eruptions to be more explosive. On top of that, it's a powerful greenhouse gas, which could quickly speed up atmospheric changes after an eruption. This forms a feedback loop. The warming volcano melts the clathrates, which release gas that enhances the volcano's eruption, which in turn upsets climate systems worldwide. In contrast to surface volcanoes, which offer visible warnings such as smoke plumes or rumbling tremors, this seafloor giant provides no such courtesy. Its stealth makes it infinitely more dangerous. By the time a surface-level symptom occurs, it could already be too late. Current computer models show that once a critical pressure point is passed, the eruption could begin within hours, not days, leaving very little time for evacuation or preparation. That's why scientists stress that what we're seeing now may be the earliest phase of an awakening, and one that demands around-the-clock monitoring. If this supervolcano were to erupt, effects would ripple around the world, not locally. Ash clouds might reach high into the air, encircling the globe and cutting sunlight for months. It could cool the world by 1 or 2 degrees Celsius, enough to change weather patterns, shorten growing seasons, and trigger crop failure across large agricultural areas. That translates into food shortages, inflation, and global economic shock. And then there's its impact on weather. Ocean streams such as the Gulf Stream would be disrupted, altering weather across Europe and North America. In some areas, drought, others, flooding. The marine food chain would see its own doomsday arrive. Ashes and pumice falling on the sea to form huge dead zones. Areas so polluted and lacking in oxygen that plankton, coral reefs, and fish would die. This collapse would have shockwaves rippling up the food chain, wiping out fisheries and coastal economies that depend on seafood. The economic costs are mind-boggling. Ports would close, international trade routes would be severed, and undersea internet cables, vital for global communication and finance, could be cut by seismic activity. Insurance claims would soar and stock markets could collapse under the weight of uncertainty. But most chilling of all would be the social cost: panic, disinformation, and failures of confidence. Governments would be strained to the breaking point, coping with mass evacuations, shortages of resources, and civil disorder simultaneously. This potential has rekindled desperate demands for global readiness. Currently, there is no worldwide early warning system specifically designed for undersea supervolcanoes. Some countries have begun making small moves, evacuation planning, constructing more resilient infrastructure, but these are piecemeal and grossly underfunded. Public education is minimal. Most residents of coastal cities are unaware that a time bomb is ticking beneath the Atlantic. The absence of education could be disastrous when minutes count. Other scientists contend that what is required is an international task force, similar to those created for asteroid defense or pandemic planning. One potential concept is the Oceanic Supervolcano Risk Index, or OSRI. This would score underwater volcanoes according to live pressure fluctuations, gas releases, and seismic activity, enabling governments to target resources according to threat. Imagine a volcano version of a hurricane warning system, but one that operates quietly under the waves. Unfortunately, only a handful of countries even have the tools to monitor these deep-sea environments. Data sharing is inconsistent, sometimes even restricted due to national security or funding gaps. If one nation detects warning signs but doesn't share the data in time, the world could miss its only chance to prepare. The danger isn't just the volcano, it's the lack of communication and collaboration. Without a unified effort, we're all at risk of being blindsided. Supervolcano emergency preparedness needs to become a routine aspect of international planning. Just as we practice earthquake drills or prepare for tsunamis, coastal cities need to have eruption simulations, tsunami procedures, and stockpiling of resources. We require backup communication systems, redundant satellite networks, and emergency shelters that can accommodate mass displacement. This is not merely a scientist's problem, it's a human survival problem. Because if the volcano erupted today, cities such as New York, Lisbon, or Dakar might be under threat immediately. Coastal communities would need to be evacuated on short notice. Transportation networks would be swamped. Governments would have to mobilize military resources simply to keep the peace. And in the disorder, necessities such as clean water, electricity, and medicine might be in short supply. Panic would propagate quicker than the ash cloud, sustained by misinformation and fear. Political alignments would be strained as countries rushed to secure their own nationals. The ripples would propagate to every nook of the world, psychologically, socially, and economically. But in this crisis is a potential. The confirmed existence of an actual, presently active supervolcano under one of the world's most crowded oceans might be the wake-up call we so desperately require. It might drive us towards global unity in a manner that few topics ever would. The methods to monitor and prepare are already at hand. The science is unmistakable. The political will and public urgency to act before tragedy befalls us are lacking. So what are we going to do now? Will we meet the challenge, or wait until it is too late? That's still a mystery. But the Atlantic supervolcano isn't waiting for us to get our act together. Its timeline isn't political, it's geological. And the clock could have already started running. Let us hear your opinions in the comments below. What are we supposed to do now to prepare? How do we weigh scientific urgency against public realism? And do you think the world will come together in time, or sleepwalk into disaster? Don't forget to like, subscribe, and click on that bell icon for more eyebrow-raising revelations from the cutting edge of science and history. Stay curious and stay awake.